Hello everyone, and welcome to this class on quantum mechanics and quantum computation. My name is Umesh Vazirani, and I'm a professor at the University of California at Berkeley. Here at Berkeley, we are very excited to be part of this revolution in education, bringing cutting-edge courses to anyone in any part of the world. So what is quantum computation? Quantum computation is a very young field, which is based on the discovery that quantum systems can be exponentially powerful. I'll say a lot more about this in subsequent videos, but in this video, I want to talk about the format of the course. The course is offered over 8 weeks, followed by a final exam. The material will be presented through a series of short videos, which will be augmented with inline quizzes to help you reinforce your understanding of the material. There'll be 7 problem sets, each worth 10% of the score. And the problem sets will have mainly multiple choice and questions with numeric answers, which you will turn in. To make sure that you understand the material really well, we'll allow you to make multiple attempts at the problem set. After your first attempt, every subsequent attempt will be penalized 10%. If you want to understand the material at greater depth, we'll also include optional long questions. These you do not have to turn in, but you are welcome to discuss these with your fellow students in online forums, which I'll talk about later. The final 30% of your score will be based on the final exam, which you can think of as a particularly long problem set. Okay, so what's the required background for this course? So this course has been carefully designed to make it accessible to students from a multiple of backgrounds, including computer science, physics, chemistry, mathematics, etc. And so we've tried to minimize the number of requirements for this course. So in particular, I'll not assume any prior knowledge of quantum mechanics. But to take this course, you will need to have a thorough understanding of basic linear algebra. What I mean by that is simple concepts such as vectors and matrices, orthogonal bases, inner products, eigenvalues and eigenvectors. To help you review your knowledge of this material, we will include some sort of supplementary material and perhaps a video about this subject. I'll also assume very basic knowledge of computer science, things such as the big O notation, or some elementary algorithms, but particularly how you analyze the running time of algorithms by counting the number of steps. There are a few other important issues we should go through. This class has an honor code. This is the same kind of honor code we have for our in-class students here in Berkeley. So you are allowed to discuss the material in this course. In fact, you are encouraged to discuss the material in this course with your fellow students. You can even discuss the problem sets with your fellow students, to ask clarifying questions, etc. But the answers that you turn in have to be your own. In addition, we'll request that you not distribute online the problem sets or any of the answers that we post. This is so that in subsequent offerings of this course, the students are allowed to work independently on these questions. I'll be posting course notes every week. You should think of this as a textbook for the class. This brings us to the question of time management. So you should expect to spend anywhere from 5 to 12 or more hours per week on this course, depending, of course, on the kind of background you bring to this course, and also the depth to which you want to understand the material. So the material is going to be formulated so that you can understand it either at a high level, or if you want to, you can use this material as a springboard to understanding the various aspects of this material at a greater depth. The course notes will help you to do this, as will the optional problem sets. There's one other important point, which is that there's an online discussion forum for this class, which will allow you to interact with your fellow students. This is a very important part of the class. This will make it more fun for you, but it will also allow you to understand the material at a greater depth. You're also encouraged to form study groups, either physically or through this online forum. Okay, so what will you learn in this class? So as I mentioned, one of the key aspects of quantum computation is the exponential power of quantum systems. So in this course, you'll learn what is the source of this power and how can you use this source, how can you exploit this power to design quantum algorithms. By the end of this course, you'll understand several iconic quantum algorithms, including the quantum algorithm for factoring integers efficiently. You'll also learn what are the limitations of the power of quantum mechanics. In order to do all this, you have to have an understanding of the basic quantum mechanics. And so another way to view this course is as a simple and conceptual introduction to the basic elements of quantum mechanics. Okay, so I look forward to having you in this course.